Hello and welcome back to Compiler Programming. Today I want to work on literal types. It's a concept that is not really present in a lot of languages, mostly because it um, doesn't really make sense usually for compiled languages, but I think I figured out how to make it nice. So let me show you what I mean. The only language I really know that has it is TypeScript. So there is this concept of literal types, and the idea is that you can have a function, and if you statically know that the function input is uh, of particular value, not just a type. So I don't just say like there is a general one that is tag name string, but there is a very specific one, which is like, for example, it's an image or it's an input. Then you can have an overload that will either resolve to a different type. It will, I don't know, do something different, maybe faster, and so on and so forth. C++ also has a limited version of that. I believe you can do it with templates, and but it is very hacky and limited there as well. So there is that. Yeah, I think it's a very good thing to have because it should allow to move a lot of what is typically optimizations that are inside the compiler into optimizations that are defined in the userland. To give you an idea, for example, if you imagine that we have something like x multiplied by 1, right? That is obviously an operation that doesn't do anything, right? It's just going to be x. So we would want to optimize that out of the program and leave it with just x. So things like that are rewriting rules, and obviously there is a limit on what you can do with overloading, which is exactly the same as what we had with constant folding. For example, if we have something like x plus 5 or x plus whatever plus 6, right now our constant folding will not be able to figure this out, and the same is with overloads. You cannot like match on the more complex expressions. So that's just a limitation, but it is still better than nothing. And there isn't really a lot of cases where you do need to do something like that, except for maybe constant folding and some kind of logic stuff. But as far as logic goes, we'll have to handle it separately. Anyhow, I still want to have literal types because they're useful for a lot of different things. And as I said, they're also useful for stuff like this, where you have x plus 0 or x plus 1, and that should be something else entirely. Okay. Before we jump into that, the way I'm going to implement it is actually with the previous version of macros that we right now have sort of commented out, and I thought about it in the middle, and I think that it is actually closer to what I want than maybe what was in the last video. I haven't decided yet. Right now, I'm just trying to crank out as many things as I can that will provide the functionality that I want, and then somehow put it all together into something nice and figure out what combination of inline function, macros, procedural macros, whatever we want to have to cover all those cases. But for now, I just want to try to cover them as broadly as possible and try out different things and then decide what works and what does not. So let's start with this. We will uncomment these tests and comment out this one. This should actually, this also stays commented out. Macro, that sounds good. And I think there is one more, which is maybe here or maybe not. I guess I have actually, okay, yeah, that actually already is around because that doesn't make any sense. Okay. So I did smaller factoring between videos, so I just extracted that whole ordeal with calling macro with lazy arguments that we worked on in the last video. And that means it should be very easy to disable it. So I will just do that and say to do consider uh, how this should be exposed in the syntax. For now, we're just gonna remove that stuff and uh, re-enable this. Okay, so return value. Okay, and do it like that. And this is no longer a thing. There is something missing over here. Actually, take a look. Result value. Return value is result value. I think maybe not. Maybe that's all there is to it. Okay, what's wrong now? Oh, we don't have the function declaration. That is very easy to fix. We're just gonna put this one here. Okay. What else? argview is not used, so that means that it's gonna be folded into this one. This. Okay. Good. Let's see if that passes our tests. It does, and let's think about it. So git log, which episode are we on? We are on 131, I guess. So yeah, we are on 131. Good. Git commit and git commit episode 131. Re-enable in macros function like macros or something. Okay, now let's get back to our literal types. And they are actually not very specific to macros, but they, I think, are more useful there. Okay. Let's write a test, I guess, and see how it works out. So, should be able to parse and run macro with a literal integer type. And this is interesting because let's actually say literal S64 type. To be more precise, I do want to have sort of a way to do overloading based on the type of the argument, even if it is something like a number literal. So like U8 that is 0 might be different from S64 that is 0. And I will call this plus. It will be a macro. It will be x. And here's where it becomes interesting. So I put 0 to here, right? And I'm saying that that is actually just x. And we can try that out. plus 42 0. Obviously, that should work even now. Actually, no, it won't work because we don't have this parsing. But if I added a more general version, like if I said x, y, s64, actually, that might not be a bad test, maybe. So like this, the test should pass, I guess. Let's try. Yes, it's passing. Everything is good. But now the actual question is how to verify that it is correct. Maybe what I will do, we will call it broken plus. And what it will do is when you add 0, it will actually add 1. Something like that. And then we should say that this is actually should be 42 like this. And broken plus. Now it will break. I'm not even sure exactly where, but somewhere. Yeah, let's open up the debugger and just start looking into where exactly that breaks. Or maybe we can look at it differently. There is this token match call arguments, which is so this is something that we will need to look into. However, or more like in here. Yeah, okay. So we actually need to patch in here where we'll calculate match. But this is for the call. First, we need to deal with the parsing. And parsing is down inside of here. Token process function literal. Great, we are doing the return. Okay, that makes sense. Splitting match argument. Okay, so this is actually where we need to deal with that stuff. Token match argument. Okay. So this is what it does. It looks for an ID and then it tries to match the type. Struct field, parse definition. Okay. So let's just do the most straightforward thing we can. This seems fine. And here we would do token match match named argument maybe. Let me think about syntax actually. What am I happy with this version? Maybe. Yeah, okay. Then that is fine. I'll do token match there is this split. I think it's here. Yeah, token maybe split an operator. That seems better to me than what we have right now. So if we can split on this stuff, then we do this jazz and we say that if left hand side, tag, or if not, token match. Actually, first we need to check the size. If left hand size length is not 1, we can do an error. We can say go to error, error. So in case everything is fine, we will deal with it, but in case it's not, we will just return arg. This is just for consistency. I could just leave return 0, but this way it is more consistent with the rest of the with the rest of the error handling. Okay, that's fine. So we actually need to have two different cases here. In the first case, if we have a 0 length, then we need to say that argument definition with or maybe like this, operator expects an identifier on the left hand side. Okay, if it is more than one, then we are saying that expects only a single identifier on the left hand side. So we can do like this, or not token match LHS tokens 0 and token pattern tag is token tag ID. Okay, so now we know that on the left hand side we only have one ID and that's it. So basically it's a more elaborate way to do this line, but unlike what we previously had here, this is more robust because what this does, it says, okay, I'm looking for a definition and I'm splitting directly on the column, and I expect certain things on the left and the right hand side. So it should be more robust in that respect and give better error messages to users. Okay, so then we have the right thing. Now we can say name const star name, or actually we can do slice name is left hand side tokens 0 source, and the rest is actually now, whoops, all the rest is right hand side. Okay, and here So this goes into here. We don't need any of this stuff. Is it okay? Apparently not. So the first one is token maybe split an operator needs to be brought way up here. That's not a problem. What else? Yeah, this needs to be here. Struct, so this is source, name, and type descriptor. Okay, and great. Else, panic to do literal types. Let's disable our literal type test for now to verify that our refactoring actually didn't break anything else. It didn't. So let's actually commit this separately. Git add source C episode 131 improve argument definition parsing. Okay. Now we can re-enable that stuff and figure out what to do here. And what to do here is we basically treat that thing as a constant expression, and maybe later what I will do is I will even fold this stuff into constant expression, so you can do like type definition sort of as a value that you can pass. We'll see. For now though, this is what it's going to look like. Value star literal value type is value any constant allocator and parse a constant expression. Actually, I don't need to allocate. Okay, so it's like that. That's even better. Scope. Scope is interesting. Let me check with which scope we actually call this stuff. Okay, so it is called with the right scope. Gotcha. That's good news. That means that we are good here. So we try to do that. And once we have that value, the question is, what do we do with that? Because previously we would return a time descriptor and then we would yeah, that's kind of interesting. So I think what I want to do is I want to change token match arg to not return this stuff, but actually return a value. Yeah, that would be better. Arg, let's call it name, and arg value. I like that. Token match arg, where are you defined? You're defined here. Well, we're just gonna replace you with name and value. Okay, that creates a bunch of problems. That's okay. So arg type descriptor, let's replace with just type descriptor. Arg value, okay. Uh, descriptor function arguments. Well, I don't think we need that. And scope define, argument names. Yeah, I think we can just do it like this. And remove it from here. Okay, I was doing it separately because function push argument actually pushed it to the argument list. Okay. That is slightly awkward. So this needs to go back here. Is external. Okay, so this is fine here. And we need to actually change function push argument to do something else. Yeah, there is actually no reason why this thing pushes arguments directly. It should just return to us what it wanted to push. And descriptor, yes. I mean, it already returns it, so let's just not push it. Okay, remove this stuff. Generally, this function needs to be rewritten because right now it's hard-coded to only support like Windows calling convention, and we need others as well. So that's something to consider. And probably I want to rename it into function next argument or something. Next argument value. Sounds better. And this is what we will do. I actually probably prefer slightly different formatting here. Okay. Star arc is name. Actually, we can even put this directly into here. Yep. Token match arc. Arc. Okay. Spacing semicolon. Type descriptor is just type descriptor. Okay, it still needs the and descriptor. So function descriptor. We can pass that, no problem. And that would be descriptor function. Let's just call it function, to be honest. Key. And we have literal type. Okay, that is getting better. Argview, yes, you also need to have descriptor function here. Rate compile time eval. Value is different. Yes, the new name of that is function next argument value. And we need to say eval builder value descriptor function arguments arg value, something like that. Oh, left operand. Okay. And the same thing here. Dynamic array push. Descriptor function arguments arg value. Okay, is everybody happy now? Okay, the same trick, we will disable this test because I'm not ready for that, but I want to make sure that our refactoring did not break stuff. It didn't, which is good news. So we can continue on forward. Now, we have this literal value, and that just means that we can do essentially the same thing here. We will save this. Actually, the name is empty, so it's like this. Maybe I want to be more explicit here that the name is that. It will be something to take care of actually in the function below, because it expects to always have a name, and now there isn't one. Key arg value, yes. And value is literal value type. Okay, in the parsing, I think that's about it. And now here, I need to say if arg name length literal values do not have a name at the moment. So we should get past here, and the place where it will fail is actually here. It's not that it will fail, it's just that actually it will have the same score, so that hopefully right now if I try to run the test will just fail but not crash. Let's see if that is indeed the case. That is not exactly what I wanted to see. Passing test, did I not disable it? Okay. I guess because this was defined later, we ended up with choosing this overload over the other one. Yeah, okay, so we ended up choosing this overload. Let's switch them around then. Interesting. So it doesn't matter whether Huh. No matter what this wins. Why is that? It's very interesting. I mean, that's behavior that we want, but I'm very surprised why that works, because it shouldn't. And that is always very suspicious when that happens. Okay, so what happens here? We go through arguments. Yes. And then we get the values, and then we say if it is the same value type, then they get exact, and if it's this, and they get minus. I mean, these two should have exactly the same score. So let's actually do that. If score is match score, we should error out in this case. Steve the worst or worst. And here think we want to do it like that. Program error builder, target token, that's fine. And we need to say to it's very hard to give a good error message. C++ does a terrible job at this. I think which is do a bit better, but it is still tricky. So what we need to say here is that we tried to find an overload for this function, but we found several of them that all have exactly the same score, so they all match very well, and that is a bit tricky. Could not decide which overload to pick. And then we need to do um, provide names of matched overloads. But this is a pretty terrible error message to do improve error message. I don't know how to say this better. For now, that's not important. For now, I'm interested to just get to here in our test. This is what I hope. Okay, now I'm really, really confused. Why aren't you getting here? S64. Oh, I think I know. Yeah, I got what's going on here. Because this is still this is a S8 right now, or U8 even. And if I want to fix that, oh, this is tricky. Okay, let's do a hack. Hack. That's still gonna be not the right type. So we need to move cast into constant expressions as well. So I need to say cast S64 0 like this. And here it's x is 41, y is 0, or like this. Y is 0, and I do x and y. First of all, let's try to run this. Okay, we have a failed test because we ended up here. And this should fail because it can't find how to cast in a constant expression, I believe. Yeah. Okay, that's not the greatest error message, but we will improve that separately. For now, we need to have parse expression, and actually not really parse expression, but we need the cast. Okay, there is already a thing about making it a macro, but I haven't figured out yet exactly how to do it in the best way. So that is something to figure out. Result token is token handle cast context target args token. Actually, we don't need target here, I believe. Args token builder value any. We might not even need that. So let's try to put actually const token star token handle cast. Const token star result token return results token Context. What is args here? Args is also a token. Const token, args token. And let's see where we are right now. We need a builder function, builder. Whoops. Okay, so that extracts it into here. But we need to move it into the constant expression, but constant expression does not have a builder. So let's see what this does and why does it need a builder. Oh, the thing is it needs a builder because it does parse expression and we need to do constant expression. So that just means that we need to pass in const source range and array value pointer args like this. To const source range, yeah, you need to have a star, and here we don't need to destroy this because it doesn't exist. And here I'll just do source range, and here it's just source range. Okay, that builds, and now we can take this thing and move it way up into parse constant expression, which I think is somewhere here, or maybe here. Okay, so let's put you in here. Great. And now we take this stuff and we move it into constant expression. Yes, we move it over to here. Match call arguments. That needs to be done with constants. So you actually need to go into here. Else if function. Great. Yeah. So now the trick is we need match call arguments where The arguments are actually constant. Hmm. How would that work? Let's see. Maybe I should have just made it such that if there is no builder, it uses constant expression. If there is one, it uses regular one. Maybe. But for now, I will just do it more explicitly. Match constant call arguments. I know they are the same, but it's I'm not exactly sure that this kind of overloading is a good idea. So let's actually do it like that. Let's leave this comment as well. You don't need the builder. Compatible types, value star to scope star. Context scope. Actually, let's do scope star scope, I guess, like this. And here, match constant call arguments. And well, I guess I don't need the scope after all. So let's do context scope. Args token, it's not called args, it's just called args. Okay, arg values, maybe? Result token undeclared identifier. So it's just result. Args token, yes, it's just called args. Okay, we are just left with handlecast. Wanting a builder, but you don't need the builder anymore, I think. Oh, you do. You do because you wanted to do this. For now, I will just I think I will do this. Not implemented cast to a larger type. Like you technically don't need these casts, at least for integers, and the rules are a bit eerie anyway. So yeah, let's do it that way. Different const qualifiers. One source range. Const modifiers. Oh, what? Okay. And you don't need the builder. Again, this was quite a few changes, so we are disabling these tests and try to run all the rest. All the rest is fine. Re-enabling this and let's continue to see what's going on. Not implemented cast to larger type. So that's exactly the message I just added. To a larger type. But here's what's going to happen. I will say that if result if value okay, if value operand is immediate, value operand operand, not operang. So with immediates, we can do the following trick, I think. We say value. I need to know if it is signed or not, because I need to figure out if I need to do a signed extension versus unsigned extension. I think I have this is signed or something. Is signed? No, no. And here, maybe it's in value h. Value h is signed integer. Okay, yeah. Here I need to say that if descriptor is integer, value descriptor and operand is immediate. Okay, now we do if descriptor is signed integer. And we do this stuff. Else. So for unsigned integers, actually very simple. We literally just overwrite the descriptor. We don't change the actual operand because operand should be correct. Although it might not have initialized memory, so that's awkward. Okay. Actually, we don't need to check this stuff. Okay, so it is an immediate. If it is a signed one, okay. Switch of value descriptor. Case operand result. Operand is the following. So tag is operand tag immediate. Oh, yeah. So we also need this stuff. Yeah, the whole immediate is a bit awkward to work with, to to be completely honest with you. Hmm. Well, this just means this is going to be a very ugly function. That is okay, I guess. Value up. And this is also wrong. This does not really work for immediate. Hmm. I wonder if this now needs to be on the outside. Yeah, let's just move it on the outside. Has to byte size. Case 1. So if it is a signed one, then we would say signed immediate or integer is what is it from or S64. Yeah, operand immediate as S64 value operand. That's fine. If we have one, then we will do okay, cast descriptor operand is tag operand tag immediate 8. Byte size is cast to byte size, and immediate 8 is S8 of integer. Something like that. Okay, now we need to have 2, 4, and 8, of course, and then we have unsigned ones. And I will leave unsigned ones, I think. Panic to do implement signed extension. Just so to try to shorten the video because it's already running a bit too long. 16, 16, 32, 32, 64, 64. I think I might turn this into a macro or something. And default break panic and supported integer size on casting. Does that make sense? Yeah, I think that is now called immediate 32. Is it like this? Okay. Immediate 64, immediate 16, and immediate 8. Okay, one more time without the test to see if his bus still works, because I think it's the only test that actually uses casts. Okay, seems to be fine. And getting back here, and let's see what is happening. Using descriptor is assigned integer. Okay, so we did end up with unsigned one. Okay. Um, how do we want to deal with that? It's basically the same thing. The only thing is this is here, and here I need to be like this. And here I'm doing you, and you. So the difference is in the most significant bit. For signed ones, we need to move it either in one direction or into another direction when you're doing this cast, and for unsigned ones, we just truncate essentially. But actually, I shouldn't be looking at the value descriptor. I should be looking at the cast to descriptor, this thing. This is what I should be looking at. And this is why I shouldn't be different. We shouldn't actually need the unsigned ones. Okay. So we are not panicking anymore, but we are not parsing either. Now we'll start the debugging session, because now I'm not exactly sure where this is actually happening. I need to somehow improve the parsing. So because a lot of the times I end up in here and I don't know why. So somebody gave me a null token back, and this is a side effect of how we deal with errors. Okay, so where are we? That is the most interesting question. We are in token check ID, and we have broken plus x, y. Okay. That is probably in here. Token value make. Where was it? It was in here. Token value make. Let's try again. Okay, great. Yeah, I think the rule will be that tokens should never be 0, but values can be, or something like that. Or maybe I even will create a special value that is like a poison value, whatever it's called, that says, okay, this is actually broken, but I'm just here so that the rest of the program does not explode. Good at stage reach overload peak. Great. That is finally what I wanted to hear. And I actually want to probably add a test for that. To do and a test for this case. Now, calculate argument score. So it returns S64. It means it actually is very big. Maybe let's do here, and there will be another tier, which is exact type, and here's exact value. There is also a question on casts. When you have two immediates, will they cast? Like, what takes precedence? Is it more important that both of them are literal types, or is it more important that both of them, like the fact that they need to be cast? I don't know. Maybe I will add a comment here to do consider relationship between casts and literal types. Exact literal, and let's add a few zeros in here, or maybe this will be 1,000 and this will be 1 million or something. So this will might be broken on a 1,000 argument function, which is not something that you should have in your program. I mean, you could, but maybe I will say assert less than 1,000. Okay, so we'll put here exact type, and now I will do the following. If operand is immediate, this will, what I'm doing right now, all of it will only work for integers right now, and that's because we don't really have string or any other kind of literals, which will be a separate video. But for now, we focus on this. So operand is immediate. Of what? Target arc operand, something like this. So if both of them are immediates, then we can do the dance, right? And else, switch of so I want to assert that target argument operand tag is the same as actually I can do this operand equal I can even do this because if one of them is not immediate, then they're not going to be equal. And this goes here, and this goes here. Okay, so now we should get our test passing. Let's see. We do not. We still said we have no idea which operand to pick, so that I guess means that we never end up in here. Let's check that in here. So my guess is we never get to here. Indeed, we do not. The question is why? Oh, yeah, I know why. Because my test is wrong now. Yeah, the whole situation with casts and literals is going to be interesting. So I'm definitely glad I'm actually trying to do this thing. I mean, it's not terrible. It's not the best syntax to force a specific type. So I still need to think a bit more about how integer literal types supposed to work in relation to overloads. Let's try again. And here we go. We actually have it working. To verify that, we can also get in here and we get the right thing. So that's great. This is exactly what I wanted to have. I said I'm not in love with the syntax because I have to explicitly like cast a number to a specific size, and both in here and in here, but that is a completely separate topic from the feature itself. And the feature is that now we can put something literal in here. For now only integers, but we will work on other uh, literal literals of, I don't know, structs or strings or whatever, and we should be able to match these more precisely, which is great. So that would be all for today. Thank you very much for watching, and hopefully see you next time.